So the first question is, combination lock opens with the correct 4-letter code. Each wheel rotates through the letters A to L. How many different 4-letter codes are possible? So 1, 2, 3, 4. We can take 4 spaces because we can put one thing in each space, right? And if we can put one thing behind in each space, we can use the fundamental counting principle. A to L is how many letters?
12.
So it's going to be 12, 12, 12, 12, because it doesn't say anything about restrictions, right? Which is 12 to the power of 4, which is?
20,736.
Boom. Good one. Okay. The next one says same thing, each wheel rotates through the letters A to L. Suppose each letter can be used only once in a code. Indirectly telling me you cannot repeat. How many different codes are possible when repetition is not allowed? So we're going to have 12, 11, 10, 9, which is? Boom. A restaurant offers 60 flavors of wings and your choice of 3 dips. How many variations of wings and dip can you order? So it would be 60 times 3. This would be wings. I'm choosing one kind. Dip. Choosing one kind. 180. 14P7 is literally, do you remember where the button is? So if you did, it is which one?
You go to math, and then you go over to problems, and then it's
Yeah. B. 5. Suppose a word is any string of letters. How many 3-letter words can you have from the letters in Regina if you cannot repeat letters? So Regina has 6, 5, 4, which is?
120. Are you sure it's what?
Is 4B?
Someone told me it was B. Who lied? Liars. Someone said the second one. I'm not
No, that's the second one on the calculator.
Oh, I think it was the second answer.
Math, and then you go back one. And
Yeah, you go math, left, number 2.
And the second one.
Yeah. Yeah, you go 14 math, probability number 2.
Yeah.
The second one. I get what you're going with, but I thought you meant that.
No.
Which I thought was a small answer, but whatever. I wasn't going to, take it down. So, 120. Here we have Lethbridge, 2-letter words. Lethbridge has 4, 8, 9, 10. 10, 9, 19. How many numbers are there from 900 to 999 that do not have repeated digits? What do we have to start with?
1, because it's only 9 in the beginning.
We start with a 9. So yes, I thought you were like, we start with a 1, and I was like, no. But yes, one option. Yeah, I get what you're saying. This is true. It has to be a 9 and we have no repeated digits, so we box it. Yeah, we box and move on. So how many options do we have for the next? 9, because we have 0 to 8. We box the 8. We have 0 to 7. Which is 72. Okay. NP4 equals 120. We know from the NP4, we know what about N?
N is something, or not repeating, sorry, something down to.
Something down to 4. So we know we have 4 blanks. We agree with that, right?
Yes.
We know we have to have something down by 1 4 times. That would get me 120. We know that. We know N has to be what? 4 or higher, right? It has to be 4 or higher because N can be, you can do 4P4, you can do 5P4, but you can't do 3P4, right? You can't have 3 and then pick 4. That doesn't make any sense. So we know we have 4 blanks, and we know it has to be bigger. So if we went, it could be 4. We could go 4 times 3 times 2, just proving a point, which is 48. So, it's 4 blanks. Left, 4 blanks. Still 40. 24. 24. Okay, and then, or we could try 5. We could try that n would be 5, then it would be 5 times 4 times 3 times 2, which is 120, which is right, which is A. Now, you probably went 5p4 and got 120 and moved on. Totally fine, but what if they ask you to explain why?
I used my calculator.
That is not an explanation. So you could show it by fundamental accounting principle, or you could show it using the formula off your formula sheet. Your formula sheet's over there. That's not yours. That one over there.
I don't understand why you can't put trial and error as a valid answer for how did you get this.
That's not an explain.
But it's like, it's explain how you got this. And it's
No,
just
it's
trial
not. That's
and
not trial and error. Trial and error is like you've done math, you trialed it, and you errored. So like I trialed and errored. You punched into your calculator. That's not trial and error.
But you have to like punch in the different numbers to figure out.
That's not trial and error. That's you just punching stuff in. Your calculator's doing the work.
Okay.
So trial and error means you're doing the work, and you're trial and error. So I trialed and error. I went 4, 3, 2, 1. You guys stop talking. I went 4, 3, 2, 1, and I got 24, and then that didn't work. So then I went 5, 4, 3, 2. I'm doing the trial and error. You were making your calculator was doing the trial and error. Now you. Yeah.
I'm sure you talked about this. The number on the right is like how many like lines it. So if it's like 12, it would be 12 lines.
Yes.
And then the number on the left is what number you started.
Yes. You are correct. Okay. You zip it. Okay. So 9PR, we have to figure out how many. So we're going to start at the 9, which is exactly what you just said. So we start at the 9, and we need to figure out how many blanks we need to go down by to get us 72, correct? Rather than just using your calculator. So let's use math. So we go 9, then 8. 9 times 8 is 72. I'm actually done. So it's going to be 9p, 2 blanks. So it's B. I didn't need my calculator, right? And we want to be able to do stuff without our calculators because if there's explains, describes, compares, any of that stuff on your test, you can actually do it rather than just say, I use my calculator. Because if that's what your reasoning is going to be, I use my calculator, you're going to need more than that. An explain or describe. That's not going to work. I press the buttons this, this, and this is also just a fancy way of saying I use my calculator. Still not going to work.
I made my calculator do the trial and error for me.
Yeah, that's not going to work. How many ways can 7 friends stand in a row for a photograph if Shang always stands beside his girlfriend? I set you up for this one. This is what we're leading into today. So let's see how you did. Okay. 1, 2, 3, 4, 5, 6, 7. How I do these. So I literally set you up. I have not taught you this yet. Just wanted to see how you do. Okay. So Shang and his girlfriend have to stand side by side. So what I always do is I force them to be together because they have to be side by side. So I hook them together. So I start with that. Let's see if you get the same answer. Might get there. So I hook these two together. Paying attention? Okay. How many options do I have for this blank? 2. There's 2 people. Adrian, now, how many do I have for this one? Yes. Okay. He was just ahead of himself. So I have 2 times 1. We agree? And I hook them together, so I'm making them stay together. How many people have I placed now? 2. How many do I have left? 5. Do I care in what order? No. So I have 5 for this, sit someone board for this, put someone in, standing, they're not sitting. 3, 2, 1, and I have to multiply them all. And that's the answer that most people will give me. But there's another step. Because the catch here is that if we just do this, they're together, but they're together at the front, correct? Does it say that they have to stand together at the front? No, it says they have to be together. So what we're going to do is we are going to move them. Close.
6 times.
Yes, 6 times. Because we're going to have 1 here, then move it here, right, which is 2. We could take them, we could physically move them here, which is 3, move it here, which is 4, move it here, which is 5, and then move it here, which is 6. Did I teach this? I 100% did not teach.
I thought you did.
No,
but
you
maybe I
stopped
missed it.
before it.
I did.
Guessed it.
Yeah.
Jesus.
Do you have a
Oh,
quick
I
catch?
stopped like right before it, and you were the genius. And then all you genius after with his genius. It's like your genius spread. Okay, good. Yeah. It is always, it's a good disease to get, the genius disease. Okay. So this is the thing. Please pay attention because if you do this, you aren't even going to have to draw arrows each time. Okay? This number that we multiply by is always one more than the number after the hook together. So if these are hooked together and this is 2 and 1, I don't really care what those are. I care what this one is. It's 5. That's going to actually create 6 more places that it could go because it's 1 in front, 2, 3, 4, 5, 6. So it creates one more space than this number always. So we're going to multiply by that number, okay? Now, I don't want to lose you, so we're paying attention. This can be written like this as well. 2, 1. 2 times 1 is just 2, but they could write it as 2 factorial, technically, if they wanted to, but are they going to? Probably not. So that's 2. This is where I'm going to lose you. So remember, if I can go to blast off, that's a rocket, right? So if I go 5, 4, 3, 2, 1, blast off, that's the rocket count, which means I can put a factorial. Can I not? With these, because this number is always one more than this, I can make it join it. So instead of writing 5 factorial times 6, I can go 6 times 5 times 4 times 3 times 2 times 1, blast off, and write 6 factorial instead. So you could write 5 factorial times 6, but they're probably going to write 6 factorial. They're going to make this be 6 factorial. So remember I told you it's always one more, so it can join that number and make a larger rocket countdown. Okay? Does that make sense? So then that's going to be, I'm blanking, what, 1440?
Yes.
Okay. Because this is 720. My brain just blanked on 6 factorial. It's like, it's gone. It left the building. But it came back. It's okay.
I have it written in front of us and none of us said anything either.
Yeah, thanks. Anyways, good on you if you got that. Good job. Way to spread the genius. Okay. If you didn't, I hadn't actually taught it to you, so you should be. So, yay if you did. Blah, if you didn't. It doesn't really matter. Okay. 8. How many ways can 8 friends stand in a row for a photograph if Molly, Krista, and Simone always stand together? So this is another one of those. So I'm going to give you guys time to try this one if you didn't get the lesson right. So try it out. I'm going to give you just a couple minutes. So we're going to line up 8. 1, 2, 3, 4, 5, 6, 7, 8. We're going to hook together these 3. Molly, Krista, and Simone. So how many options are for this one? 3 then. 2 then. How many people are left? Is it always 5 because in 2 cases we've had 5? No. I get that on tests all the time. Well, for 2 examples you had 5, so it must always be 5. It's 5 because I have 3 done already, right? So 5, 4, 3, 2, 1. Am I always going to multiply by 6? No, I'm multiplying by 6 because it is 1 more than the 5, right? That's the only reason why, not because I always multiply by 6. So I'm going to multiply by 6. So 3 times 2 times 1, blast off is 3 factorial. And then 6, 5, 4, 3, 2, 1, blast off is 6 factorial. B. Good job. Okay. So in B, we have 3 red cars must be parked side by side. How many ways can this happen? This is the genius moment. I remember it now. So we have 3 red cars. So how many will we have here? 3. Then 1. How many are left? 4. So now we have 4, 3, 2, 1. Now if they said, and this is what happens, you guys will get so good with the side by sides like this, and you'll multiply by 5, which is perfect for this one, that when I give you a question where it says must be side by side at the front or the middle at the back, you're still going to multiply by 5. And would that be correct? No. So we have to make sure that we read really, really, really thoroughly. Because if I say at the front, middle, or back, you're not going to multiply by the 5, right? And will the answer be there with the multiply by the 5? Absolutely, it'll be there. It'll be wrong, but it'll be there. Okay? So in this case, it is correct to multiply by the 5 because it just says that the 3 cars must be parked side by side. It doesn't say at the front or in the middle or at the end. Okay? So there's this one way, 2, 3, 4, 5 places that we could put it. We could take these 3 cars and put it between these ones. We could take these 3 cars and put it between the 3 and the 2. We could take these 3 cars, put it between the 2 and the 1. Take these 3 cars and put it at the back, right? So there's 5 different ways. So that's why we multiply by that 5. But instead of having to draw the arrows every single time, it's just always one more than this after them. Okay, so you don't put the wrong number. It's just always one more. So this is going to be 3, 2, 1, blast off, 3 factorial, and then 5, 4, 3, 2, 1, blast off, 5 factorial, which is 720, I believe. Only because, what's 3 factorial? 6. What's 6 times 5 factorial? 6 factorial, 720. So you can do that. All right. A social insurance number, the SIN in Canada, consists of 9-digit number of a 9-digit number that uses the digits 0 to 9. If there are no restrictions on the digits selected for each position in the number, how many SINs can be created if each digit can be repeated? I have to read really slow because when I listen to my podcast, I talk very, very fast. So if I speak slow in my head, it's probably normal speed, is what I've decided. So, because I was listening to a podcast from Friday, and I was like, I have no idea what I am saying. Like, I couldn't even know what I was saying. I did have a mask on for period 4, because like everyone's like right up in my grill in period 4, but like I was like, I have no idea what just happened because it's muffly and fast, and it was just a debacle. Like if I had to listen to that podcast, I probably just cried and not listen to it. That's what would have happened. So trying again on the Tuesday, talking slower. That's what's happening. So we need a 9-digit SIN. We can repeat, correct? So we would have how many blanks? We could have 9 blanks, right? And we'd have the numbers 0 to 9 in each. So this is 10, 10, 10, 10, 10, 10, 10, 10, 10. So that's actually 10 to the 9. Now, when you can repeat, can I use the little p from your calculator? When's the only time I can use the p? When an order matters, when I start at a number, when I go down by one number, each blank, correct? That's the only way I can use the p. Start at a number, p, however many blanks I go down by, as long as I'm going down by 1, correct? Am I going down by 1 here? No, so I can't use the p. So my answer is 10 to the 9. Nope, there totally is. I'm just coming to. So then it says, how does this compare with the number of SINs that can be created if no repetition is allowed, and it must start with a 6? So I have to start with a 6, so I have to start there first, right? Restrictions always happen first. How many 6s are there? 1. Then I box that because I have no repetition, right? So then I have 1 to 5. This is 1 to 5. Let's try that again. 0 to 5. 7 to 9, which is how many? 9. Then I'm going to hold 1 each time. So then it's going to be 8. Then I hold 1. 7. Hold 1. 6. 5. 4. 3. 2. Now, this can be represented in a whole bunch of different ways on the diploma. 9 times 8, 7, 6, 5, 4, 3, 2, 1. 2. Sorry, no 1. Technically the 1 could join it, but either way. I could represent this, and I want to be able, you to be able to represent it in a whole bunch of different ways, because what if it's a numeric response and they write it as NPR, determine the value of NR, respectively, and then you just write the numbers, right? But you only know how to do this, then you can't answer that question, which would really suck. So we don't want that. I want you to know how to do it all the ways. So we're going down by 1 number each time. If we're going down by 1 number each time, we can use what formula? We can use 9 factorial because it's 9, 8, 7, 6, 5, 4, 3, 2, and 1. What if we didn't have the 1? Could we still use 9 factorial? Yes, because multiplying by the 1 doesn't really do anything, right? It would still get me 9 factorial. So this can be represented by 9 factorial. Or what other way could it be represented by? Right. Yeah. So we start at 9 as our number. We go down how many blanks? 8 or 9. 8 or 9. Because if we make this 1 actually join it, it would be 9p9, which would give the same answer. If we don't make the 1 join it, it would be 9p8. Good work. Try it out. Same answer. Because what does that 9p8 and 9p9 make a difference of? One is multiplying by a 1 and one is not multiplying by a 1. And when you multiply a 1, it doesn't do anything, right? So that's why they're the same answer. Okay, you're going to try 1 and 2. Go. So 2 letters from Golden. How many letters are there? 6, then 5. Or I could go 6p what? 2, which is still 30. 3 letters from Chapters. 1, 2, 3, 4, 5, 6, 7, 8. So I go 8 times 7 times 6. Or I could go 8p 3, which is? 4 letters from Wealth. 1, 2, 3, 4, 5, 6. So we go 6 times 5 times 4 times 3, which is? 6p4, which is? Sorry, pardon? Thank you. 1 letter for the word value, 5. So I could represent that as 5p1, which is 5. Number 2, I'm going to start because everyone forgets about this one. In a 10-team basketball league, each team plays every other team twice. So not every other team, not like this one skip this one, this one skip this one. It means like every other team in the league, they play each other twice. Okay? So they're like in their own little Corona COVID league, let's say. Okay? This never really worked before, so there's a positive with Corona COVID. You understand, you're in your own little tiny league, you only play your own little people. And you have to play them each twice. So once home, once away. Okay? So how many teams do we need in basketball to play each other at a time?
Wait.
What?
Oh, I thought, sorry, I'm like thinking out. I thought it was like players on each team.
Ah, yes. There's lots. I don't even know. I suck at that. So it would be 1 team and 1 team, so we need 2 teams to play each other, right? So how many are we choosing to play each other at one time? 2. So that's going to be our R. If we're making order matter, home and away matters, correct? So then I can go P. Because if I choose P, then that represents home and away. This 2 does not represent home and away. This 2 represents how many people are playing at once. How many teams are playing at once? If I probably said people, that might have messed you up. How many teams are playing at once? So 2. So we have a 10 team, and we're choosing 2 to play at a time, right? That's what it's saying. The P, when you use P, You're saying that there's home and away. Okay? So this is representing them playing each other twice. The 2 doesn't represent the twice. The P makes it represent the twice. If they played each other once, I would have to go 10P2 and take my answer and divide it by 2. Because this is them playing each other twice. This is a home and an away game. Alright? So if I wanted them playing each other once, I'd have to go 10P2 divided by 2 to get it them playing each other once. Because this represents twice. This represents home and away being different. This represents team blue playing team red playing team blue. Like, that gives you 2 games. Okay, so P makes order matter. So this is twice. Does that make sense? That's a home and an away. So if I wanted them playing each other once, I would have to divide by 2. Or we can use combinations, which we're going to do later. What's 10P2? 90? Everyone starts off with great vigor. 7,570,000. 1,570,000. And then I get like, pardon? They're like, 1,700,000. I'm like, quit cutting off on the end. Stop it. That's what y'all do. Y'all. The mask is making it a little bit worse with the when I talk to people. Okay. In a competition, on the back of a cereal packet, making it sound intriguing. Yes. 7 desirable qualities for a kitchen. For example, spaciousness, versatility, etc. Must be put in order of importance. Oh, we're putting it in order. What does that mean? It's a NPR or permutation. And we can only use NPR when we do not repeat, right? And we're not repeating them. We're putting them in order. So we can use NPR or we can use the blank, right? Fundamental counting principle. But we know order matters because we are not going to use black. That's not going to help. We're putting them in an order. It like blatantly screams, permutation. That's what it does. It's screaming that at you. Like, yeah, yeah, right. The number of different entries that must be completed in order to ensure a winning order is, what can we do? There's 7 desirable qualities. We could go 7 factorial. We could go we could literally order them in front of our eyes, could we not? I'm putting them in a row. I'm going to order them. I would have 7 for this one, and then I'm leaving a quality there, like versatility. And then I'm going to have 6 for this one, and I'm leaving a quality there. Then this one 5, then this one 4. This one I'd have 3 qualities, 2, and then this is the crappiest one of all. It's just at the end. Which is 7 factorial. What's another way I could write this? 7P7. I start at 7. Or 7P6. Yeah. Because they would be the same, wouldn't they? True that. I think it's 5,040. Is 7 factorial 5,040? Or we could just put 5,040. So, now we're getting to permutations with repetition. So until now we've really looked at words like stage that don't have any doubling letters, but we haven't looked at mathematics, which has a whole bunch of A's, right? Or we haven't looked at cars with the same, yeah, model and color. So what we're going to do is we're going to line them up, right? And then we're going to make sure we take away all those situations where they're the same. Cody, stop being an idiot.
What?
I just wanted to put it on the podcast. You weren't even being an idiot.
Are you doing it?
Oh no! Please. Yes, I was. Who's excited when you tell someone not to be an idiot, putting it on a podcast? You want to normally not have it, but I just did. So it's been disappointing. Just you. Yeah, it's Grady, basically.
Oh, yeah, great.
I know one was here.
Podcast was on the whole time, never self-admitting.
Yeah, well, it's okay.
You need to like stay.
I think I should.
Right, pause it, yeah.
Okay.
Okay, so with repetitions, we have to take away all the cases where it would look the same. So for example, if I gave you eel, right? And I told you to cover your eyes and block your ears, and then, I don't know why you're blocking your ears, but anyways, and I retype it, as eel.
That's okay.
You'd be like, you're an idiot, that's the same word. And I'd be like, you're right. But I actually swapped the E's.
Yes. There's not two L's.
What?
Oh, no.
No, that's L.
No.
That's English language. That's
L.
E-L-L. L.
So it's not how you spell
Have you
it.
been
No.
spelling?
Eel, whenever you say you have to do two E's. Like eel and
You been spelling it.
sweep. Eel. Like if you use peel or sweep or eel, that's how you get the E sound is two E's, not two L's. Two L's go lo. Like spell, it would be L.
I was grabbing
See? There you go. That's your English lesson for today. You're welcome. That's all I have for English. I can't do anything else. Okay, good spelling. So, I swapped the two E's here, and it's still eel. Yes, it is. So, we have to take away the cases where when there's repetition, when we swap those things, it doesn't actually change it. Right? Okay. So let's look at the first case. Consider the stuffies example from last lesson. There were 6 ways to arrange the 3 stuffies. We had a kitty, a puppy, and a bunny. What would happen if instead of having 3 different stuffies, we had 2 of the exact same kitten and 1 puppy? How would this change it? So let's look. Boom, boom, boom. Kitten, kitten, puppy. Then what can we do? Kitten, puppy, kitten. Puppy, kitten, kitten. That's it, right?
Here's another example.
But if we did it, you wouldn't be able to tell the difference, right?
So that's like a red line.
We're not. They're going to be identical. My goodness. Okay, so this would be 3 cases. Shh. Quiet, please. That would be 3 cases. We agree?
Yes.
So how could we do this so we wouldn't have to list all the cases? Because that would really suck if there was like 10 million cases and we just said that would be not
The right mindset and do it.
no, I wouldn't do that. So what we do is we actually treat them all like they're different. So paying attention so you can do all of these. So we're going to go, okay, I can put 3 stuffies here, 2 stuffies here, and 1 stuffy here. They're all different. That's how we're going to treat it. And that's how we would have done it before, correct? The problem is they are not all different. I have 2 that are the same. We agree?
Yes.
So all you do is you treat them on the top like they're all different like before, and we just divide by the repetitions on the bottom. So we're going to go 2, and we put a factorial behind it. 2 factorial just happens to be 2. So we're going to get 6 divided by 2, which is 3. That's it. Same answer. So we treat the top like it's totally, they're all different, and then we just divide by the double and triple up. So if there was happened to be, say we had 5 stuffies, 2 kitties, 2 puppies, and a bunny, we'd go 5, 4, 3, 2, 1 on the top, just like they were all different, and we divide by 2 factorial for the 2 kitties, and 2 factorial for the 2 puppies. Okay, we wouldn't put them together. We wouldn't say 4 factorial, because 4 factorial is 24. 2 factorial times 2 factorial is 4. So we have to put the identical ones together, but not all of them together. So let's look here. Example 1. In the mountainous regions of India, China, Nepal, and Bhutan, it is common to see prayer flags. Each flag has a prayer written on it, and a color is used to symbolize different elements. Green for water, yellow for earth, white for air, wind, blue for sky, space, and red for fire. How many different arrangements of the same prayer can you make using all 9 flags? 1 green, 1 yellow, 2 white, 3 blue, 2 red. Can you see any difference between the 2 white, the 3 blue, and the 2 red? Those are just repeating ones, right? So, we technically have, and I'm going to show it as if it's a word. We have 1 green, so 1 G, 1 yellow, so 1 Y, 2 white, so W, W, 3 blue, so blue, 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 B, 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 and 2 red, so R, R. So we technically have the word Gilberber. It's a really nice word. Gilberber. Okay? How would I arrange Gilberber? The first thing I would do if this was a word is I would rewrite it as G, Y, and I stack doubling and triplings. W, W, B, 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 R, R. I stack the doubles and the triples so that it reminds myself to be like, hey, there's doubles and triples. I need to do something with it. Okay? So, how many flags are there in total? There's 9. And I'm going to arrange them as if they're all completely different. Remember? That's what we're going to do. Does it say it has to start with a green and end with a red or anything like that? Or have a blue in the middle or anything like that? No, there's no restrictions on where they need to be. Correct? So on the top, I'm just going to have 9 blanks with my 9 flags. There's no restrictions. So I can have 9 flags here, 8, 7, 6. I have to leave a flag behind or else I'm never ever going to have a prayer flag sitting out there, right? 6, 5, 4, 3, 2, 1. And that's normally all we would have done. Up until this point, that's all we would have done. Correct? However, if I put 3 B's on the end and I swap those 3 B's, it's still the same prayer, isn't it? And if I swap those 3 B's again, it's still the same prayer, isn't it? So I have to get rid of all those situations where it would be different, where it would be the same instead of, because I need all the different ones. So all I do is I treat the top like it's all the same, that they're all different ones, and that it's all the same as it was before. And then I just divide by the factorials on the bottom. So I have 2 W's, so 2 factorial. 3 B's, so 3 factorial. 2 R's, so 2 factorial. That's it. And it gets rid of all those cases where it's different. So the top can be represented by 9 factorial, can it not? Okay. Now I need everyone to punch this into their calculator because you guys are going to get this wrong. Not because I'm changing the 2 factorials to 2's, just because that would be the same. Follow along. If you have the TI-83s, you will not be able to do it this way. If you have anything but the TI-83s, try this. If you have the TI-83s, I'm going to help you in a second. Okay, so if you have the TI-83s, don't do anything right now. So there is a button on here that can pull up a fraction. So if it's a fraction, I'm going to make a fraction appear. So I'm going to go alpha, y equals, enter. And I have a fraction. Then I'm just going to type it in that way. So whenever I have a fraction, I'm going to go alpha, y equals, enter, and a fraction is going to pop up. So I'm going to show you. If you have this one, you're going to go 9, math, number 4, and on the bottom, I'm going to have 2 times 3 factorial times 2. Why did I not put the factorials on the 2's? Because the 1 is irrelevant. 2 times 1 is 2, right? Could you put the factorials? Sure. It's just more work, but you absolutely could. There's my answer. Okay? If I do not have this calculator, if I don't have the calculator that does this, I have to use brackets. Your calculator does BEDMAS. No matter what, your calculator will always do BEDMAS rules. So what's the first thing you will always do? Brackets. It will always do brackets, then exponents, then multiplication, division, then addition, subtraction. So if you want your calculator to do something as a fraction, if you always bracket the top divided by bracketing the bottom, it will make it a fraction. Because you're making it do the top divided by the bottom, right? You're forcing it to do that because it will always do brackets first. It will. So it'll do the top, it'll do the bottom, and it'll divide them. Okay? So if you want your calculator to do a fraction, you always just put the top and the bottom in brackets. So we're going to go bracket 9 math factorial divided by bracket 2 times 3 factorial. I did not press the right button. times 2 close bracket. And look, I get the same answer. Now watch if I don't put the brackets. 9, not alpha. 9, go away. I don't want you to be alpha. Factorial divided by 2 times 3. Is that the right answer? No, because what is your calculator doing? It's going 9 factorial, dividing it by 2, taking that answer, multiplying by 3 factorial, so multiplying by 6, taking that answer, multiplying by 2. Is that what you wanted it to do? No, you wanted to go 9 factorial divided by those 3 things. If you don't put those 3 things in brackets, you're going to get it wrong, and they will have that answer on your diploma. They will. Common error of the calculator. You don't know how to use your calculator. So you need to make sure you put it in brackets. Does that make sense? Because I need to drill that home because people will get this question wrong all the time, solely due to typing it into their calculator wrong, which is just a sad, sad day. Because you did all the work right. Okay? All right. So we're going to do the word Vancouver. Now, every single time you get a word from now on, you are going to rewrite it and stack because we're going to look for doubles and triples. And to this point, we haven't had to worry about it because I haven't done repetition. So we're going to go Vancouver. V-A-N-C-O-U-V-E-R. Now, it was a student that taught me this, actually, way back in the day to stack them like this, and it was genius. So I forever will now always use it. The reason why I stack is I don't miss a doubling or tripling letter, right? I think I stack the 2 B's. I also stack the B's because then what happens is my brain goes, why the heck am I stacking the B's? Oh, right, I have to divide by 2 factorial. So it's a reminder to divide by that 2 factorial and not forget. So before I even do this question, I'm immediately going to go like this, 2 factorial. Because I know I'm going to have to do it. Because I have 2 B's, right? Now they could ask me any question. They could say, determine the number of permutations of the letters in the word Vancouver, starting with a V, having the vowels together. It doesn't matter what they say. I'm going to have to divide by 2 factorial. Okay? And now I treat the top like those 2 V's are different. We agree?
Yeah.
So how many letters are in Vancouver? 9? So on the top, I'm just going to have 9 factorial. Why? Yeah, there's no restrictions on this, is there? Is there any restriction where the letters are? No, so I would do 9 blanks, and in the first blank I'd have 9, and in the second blank I'd have 8, and in the third blank I'd have 7 letters, then 6, then 5, then 4, then 3, then 2, then 1, which is just 9 factorial. So if there's no restrictions on the word, you literally just do however many letters over the doublings and triplings. What's the answer to this?
181,440.
Sorry, what was the beginning? You actually just 440? Okay, do mathematical. Go. So we're looking at the word mathematical. On the bottom, I'm immediately going to put in brackets 2 factorial, 3 factorial, 2 factorial. Because I have 2 M's, 3 A's, 2 T's. Could I put 7 factorial on the bottom because there's 7 letters? No. 7 factorial is 5,440. This is 2 times 6 times 2, which is 24. So this, if I put them together as 7 factorial, I'd be dividing by 5,440 instead of 24. Substantially different, okay? 7 factorial would mean I had 7 of the exact same letters, which I do not. Does that make sense? Okay. Mathematical story, how many letters did it have? 12. So on the top, I just have 12 factorial because I go 12 times 11 times 10 times 9 times 8 7 6 5 4 3 2 times 1. Right? Or I could have went 12p12. Because that's 12 letters. What's the answer to this one? You just give me the numbers.
199 584 200.
Do we agree?
Yes.
19,958,400. I spelled fell. Okay. Example 3. Determine the number of different arrangements of the 6 letters in the word answer. Does answer have any doubling or tripling letters? No. So do I have to divide by any factorials? No. So what's my without restrictions? No restrictions on this. 6 factorial. Because they could be anywhere, right? So it'd be 720. I could go 6 times 5 times 4 times 3 times 2, leave a letter, times 1. Or I could go 6p6. Or for that matter, I could go 6p5 just because it's the same answer, but not because it makes sense. Okay. It has to begin with an S. Once there's something specific, a restriction, please draw blanks. It will make your life better, right? So if it has to begin with an S, how many S's? 1. Then how many letters do I have left? 5, 4, 3, 2, 1, which is 5 factorial, which is 120. So we went from 720 different words to 120 just because we made it start with an S, right? Every time we restrict more and more, we're going to get less options. Okay, next. Begins and ends with begins with a vowel and ends with a consonant. Consonant is just not a vowel, right? A, N, S, W, E, R. Right? Vowels, consonants. If it's not a vowel, it's a consonant. So we have 5, 6, like 1, 2, 3, 4, 5, 6. It has to begin with a vowel. So what are my options? 2, because I have A or E, right? 2. And then I have to hold one of them there, because it's like a Scrabble tiles, right? We used it up. It's gone. Then it has to end in a consonant. N, S, W, R. So I have 4. Then I pretend to keep one there. How many letters have I used up? 2. How many letters do I have left? 4 for this blank, correct? And then I put one letter there. So how many do I have left for the next blank? 3. Then I put one letter there. Then I have 2. Then I put one letter there. Then I have 1. So I could just multiply these, or I could say 2 times 4 and put 8, because I can put those together, times 4, 3, 2, 1, blast off, 4 factorial. So it's 24 times 8. 192? Okay. That have 3 letters, A, N, and S adjacent. Adjacent just means side by side. This word means side by side. So basically hooked together, must be together. That's what that adjacent means. So, and they have to be in the order A, N, S. So do I have options in that? Nope. But it still says they have to be together, so I'm going to hook them together. So I'm going to go 1, 2, 3, 4, 5, 6. Hook these together because they have to be adjacent to each other. Side by side, together. How many options do I have for the first blank? 1. It's an A. And the next one? 1. 1. How many letters do I have left? 3. 2. 1. And I would be done if I said in the order A and S at the beginning, or at the end, or at the middle, correct? But did I say that? No, so I have to multiply by 1 more than this? 4. So it was 1 more than the hook, after the hook together, right? So it's going to be 1 times 4, 3, 2, 1, which is 4 factorial. So 24. We have one last one left for today. So that have the letters A, N, S adjacent, so they need to be near each other, but not necessarily in that order. What's the only thing that changes? You go 3, 2, 1 up here. Right. Yeah, it's going to be 3 times 2 times 1. Used up 3 letters. 3 times 2 times 1. But I still have to multiply by the 4 because these can move, right, into 4 spots. So it's going to be 3 factorial, 3, 2, 1. blast off, and then I can go 4, 3, 2, 1, 4 factorial, which is
109, or wait, 44.
So your homework tonight are those 3 questions I posted online, right? Remember I told you every so often I'm going to give you some questions to do at home? There are 3 and you have to hand them in. They're on a Google form.
Oh, we could do it on like,
Wait, that's the
They're just, you're assuming an answer on them.
so we don't write an answer on the future.
No, you will just put it into Google form and it'll let me see how you guys are doing.
Yeah, I got it.
On Google Classroom.